right in the evening sky. Oh, got that. Cool. So this is around, uh, let's see, what time is it here? Oh, this is around 5 o'clock, 5:06 to be exact. I want to go a little bit later because we want to get the sky dark. So Jupiter's out before the sky gets really, really dark. We're going to move time ahead again. Let's go up to about now. This is about 10 past 6. Jupiter, as we can see, is still there low in the western sky. I always advise people to start by looking west first. The reason you want to do that is because those stars are going to disappear quickly. They're going to set just like the sun sets. Remember, the sun doesn't really move across the sky. The Earth is turning under our feet. We're here in Maine heading east right now at about 950 miles an hour. And we don't feel it because the Earth doesn't speed up and doesn't slow down, but we see that by the sun slowly crossing the sky. And at night, the stars move at the same speed across the sky. So Jupiter's going to set just like the sun. Well, and all these stars will too. So when you find Jupiter, look right above it, and tipped on its point, you're going to see a great big square. You see the square right here? It's up, down, and back. That's known as the Great Square of Pegasus. Now, Pegasus was the flying horse. And to make it into a horse takes a little imagination. The square is pretty easy to find. It's in the western sky, southwestern sky, tipped up on one corner right here. Let's put some lines on it like that. So here's the square. Now to make a horse, remember in space, you can fly any which way. So this horse is flying upside down. This is the back of the horse right here. This is the chest of the horse. And you see a couple front legs coming out front. This is the neck of the horse with the head right here. The star at the end here, which marks his nose, is a star named Enif. So kids always tell me that he must sniff through that somewhere, like he's sniffing or something, but it's not sniff, it's Enif, E-N-I-F. So that's Pegasus, the flying horse. Now, when you see constellations in books, you often see them drawn with nice fancy pictures like this. Well, that's kind of cool. I don't use them very often because when you go outdoors, you're never going to look up and see some ghostly figure floating in the sky like that. It makes a nice artistic rendering in a book or something. I find the line drawings help you start to imagine them better. Think of them all as stick people or stick horses or whatever, and try to use your imagination to find them. And they show up a lot better because when you go outside, this is what you're going to see, not even any lines. So now you found the great square. And by the way, the horse, they don't usually draw a hind leg or a tail, just the back of the horse and his neck and head and the two front legs, and maybe use the whole square for his body. The top star, though, is actually shared with another constellation called Andromeda the Princess. She's upside down too. So think of Alpheratz, this star here, as her head. This triangle right here, follow my pointer, that's her body with a belt around her waist. Got a leg up here and a leg up here. If you come back up her body, there's her body with her belt, and there'd be one arm of those stars and one arm of these stars. Just kind of a dot-to-dot picture. Now, what you're going to find is if you get an app for your phone or an app for your laptop so you learn constellations, is they're going to draw them. This app draws Andromeda like this. Now, that's not how I just draw it, is it? I drew it with a triangular body and two legs, and they only give her one. I don't know how you make that look like a woman. To me, at least mine kind of look like a stick person. But if you get 2 or 3 apps, you'll find they always use the same stars, but they draw the pictures differently. You know, and if you get some fancy old book, they'll draw her like this, floating there in the sky. And that takes a lot of imagination to connect the dots to make a picture like that. So it doesn't really matter how you draw it. The best way is to learn a way to draw it so that you can re-see it and visualize it better. That's why I've learned to draw them the way I see them. As far as astronomers are concerned, they don't draw lines like this. They draw the boundary like this. You know, this polygon here. And any stars inside this polygon are part of the constellation of Andromeda the Princess. Now, they don't really care because scientifically, these constellations don't mean anything. All they are is a historical way of mapping the sky. And for most people today, this historical way of mapping the sky is one of the easiest ways to get around in the sky. So I draw her like a triangle body with a head on top, a couple of little faint arms, and a couple legs going down. Now, one more thing I want you to see before we leave this constellation. If you go from her head up to her belt right there, go just to the right of her belt, and you can see, you might notice there's a fuzzy little patch you can just barely see right there. Well, that's something you want to look at. If you're in a really dark spot, like you would be in Rangeley, if we were there tonight at the touring center where it's pretty dark, much darker than it would be here in Waterville where I'm sitting right now, you would see that little spot of light, which we can just barely see. If we zoom in, you can probably see it a little bit better. That spot of light is the most distant thing you can see without a telescope. And you can just barely see it with your eyes. Now, if you have a pair of binoculars and you zoom in on it, like we're doing here, you'll quickly notice that it looks like a smudge. It doesn't look exactly like a single star anymore. It looks like a star that someone tried to erase with a really bad eraser. Well, this object is actually another galaxy. This is the Andromeda galaxy, which is the closest galaxy to our own Milky Way. And with our eyes, it looks like a fuzzy patch of light. If you take a photograph of it, it looks like this. You see a lot more detail because that, you know, the sensor in your camera can gather that light over time and pull out the detail. It also pulls out the color, which your eyes don't see. So this is very much like what our Milky Way would look like if we were outside of it looking back. And this is the closest one to us. It's 2,500,000 light years away. So that means the light that came from Andromeda to enter your eyes took 2,500,000 years to get here. That's a long way. That's a long time. And yet it's the closest galaxy. And there are at least 1 trillion galaxies out there. Almost all the galaxies are moving away from us except for this one. This is our neighbor, and it's actually headed towards us at 50 to 100 miles per second. So every second, it's between 50 and 100 miles closer than it was the second before. Eventually, in a couple billion years, this galaxy and our own Milky Way are going to collide and probably turn into one giant galaxy. That'll be something to see as it gets closer. We won't live long enough to see that happen. But it is a beautiful sight in a photograph, and it's a really interesting sight with your binoculars. And to me, though, the most interesting thing about it is you can go outside in a really dark spot and you can see that little smudge light and realize that that is the most distant thing you can see with your eyes alone. Now, right beside that, you might notice this patch of light. Do you see this through here? It looks kind of cloudy right up through here. That is our own Milky Way galaxy. It goes from the northwestern sky all the way across the sky to the south, to the southeast. So the Milky Way is our galaxy. We live inside of it. Now, all these stars over here and over here, they're part of the Milky Way too. The Milky Way is oval shaped. It's actually, I shouldn't say it's oval. The other one looked oval. It's actually round. It's round like a frisbee or a plate, kind of flat, but round. And the sun and the earth are about halfway through the thickness from top to bottom. And if you drew a line from the center to the outside edge, we're about halfway along that line. So if you look towards the top, we're going to see a few stars above us. That's what you see when you looked over here. If you look towards the bottom, you see a few beneath us. That's what you see when you look over here. But if you look edge on right through here, you'll see a lot more stars. That's what that cloudiness is. Now, here you can just barely see it, right? I have the sky set for the way it would be for you in Rangeley early in the evening while there's still a little glow from the sun. Or maybe like for me in Waterville or David in Boston, even in the middle of the night. But you're in Rangeley. You got darker skies than we have here. So from Rangeley, the sky won't look like this. It might look more like that. So that's not a subtle change. That's quite a difference. A lot more stars. And look how the Milky Way really glows now. Now, some people say to learn constellations, it's a lot easier if you're in a light polluted area because there aren't so many stars to look at. The bright ones shine through and most of the pictures are drawn using the bright ones. But boy, it's hard to beat a dark sky for something really beautiful to look at. And that Milky Way is just tremendous. So remember, here's Jupiter. You see the great square of Pegasus here. And you can see see Andromeda. Let's put the lines up. There's Andromeda. And right there is the Andromeda galaxy and the Milky Way. Well, we're going to go from Andromeda, across the Milky Way, right by the constellation that's shaped like a zigzag. See that zigzag? or perhaps if you looked at it sideways, it looks like a letter W. That's a constellation called Cassiopeia, the queen. Andromeda is the princess, and this is her mother, Cassiopeia, the queen. Now, Cassiopeia was known for her vanity. She often is pictured holding a mirror and staring at herself because she loved herself so much. Andromeda is her daughter, who was chained to a rock to be eaten by a sea monster by her father. He chained her there. The reason he did that was because Andromeda compared herself to the sea nymphs, which are like mermaids. And she thought she was more beautiful than even the sea nymphs. And the sea nymphs would have none of that. So they sent a sea monster with Poseidon's help to destroy the kingdom of Queen Cassiopeia. And they found the only way to, make the sea monster go away was that Cassiopeia had to sacrifice the only thing she loved more than herself. And that was her daughter, the Andromeda, the princess. Well, she ends up being saved by Perseus, the hero, and they all have their pictures in the sky. So here is the W, and kids agree with me that W's don't look like queens, even queens sitting on thrones. I like to think of it instead as the queen's crown, a three-pointed crown, and then use the base with a little oval drawn in here. You have to imagine that because the program won't do that for me. That's the base where she'd put her head. And it looks more like a crown than a queen to me. Well, follow the Milky Way down to the western horizon, and we have a fall constellation that's going to disappear real soon. Remember, the stuff in the west disappears early. And this is called Cygnus the Swan. The swan is right in here. This star's name is Deneb, and that's the swan's tail. Draw a line from Deneb to Satyr, this star, and that's the swan's body. Now, a line is a pretty skinny swan, so I like to draw an oval between these stars. Give that bird a little heft. We get a wing coming out here, all the way to the star, then back to the tail. So that's one wing. Another wing comes out here, all the way to here, then back to the tail. Then we come back down the body to the shoulders, and there's a long neck with a head right above the horizon right here. Draw some lines on there, and they don't do the back connecting lines. I do, because I think you should, but they don't, but that's okay. So there we have Cygnus the Swan, nose diving right to the horizon this time of year. It's also known as the Northern Cross, like a Christian cross. For the cross, we just draw, this is the upright part, and the cross piece just goes to these two stars, and they ignore the rest. That's an asterism. Asterisms are groups of stars that go by another name. They might be part of a constellation, but they're not the official constellation. If we look over to the north, we find a very famous asterism, one that probably many of you are aware of. It's very low in the north this time of year. We call it the Big Dipper. The Big Dipper has 3 stars for a curved handle right here, and then 4 stars for the pot of the bowl right there. And if that's the only constellation you know, I don't mean to burst your bubble, but technically you really don't know any constellations, because that is an asterism, an easily recognizable group of stars, though not an official constellation. The Big Dipper is part of a much larger constellation known as the Great Bear. To turn the Big Dipper into a bear, imagine the handle is the bear's long tail, because you all know bears have long tails, right? Not, they have short, stubby ones. Well, there are many tales or stories about how the Great Bear in the sky got his long tail. Some say he was grabbed by the tail and swung around till his tail stretched out, and then he was thrown into the sky. The Dipper plus these 2 stars make up the bear's long body. His nose is way out front here, and a couple front legs come down like this, and the back legs come down like this. Often you'll see a line coming down this way to a pair of stars that this time of year is just below the horizon. If we take the ground away, you can see them. They're right here. And so we have a pair of one front leg there and another one here with double stars for the feet. While in the front legs, they just come down together like that. Let's put the ground back. Those 3 groups of double stars are known as the 3 leaps of the gazelle. That's an African way of looking at the sky, and it's another asterism. So constellations come from all over the planet, and different groups of people looked at the same thing and made very different things. But officially, this is Ursa Major, the Great Bear with his long tail. Now, once you find the Big Dipper and Ursa Major, the next thing most people want to find is the Little Dipper. To find that, ignore the whole bear here. Just think about the dipper. I can't shut these lines off, but just pretend they're not there. Go to the back 2 stars, the dipper's pot. They're called the pointer stars because if you draw a line up through them, they'll point you to this star. And that star right there, believe it or not, that's the most famous star in the entire night sky. That's Polaris, the North Star. And it's not the brightest star. There are 45 to 50 stars brighter than Polaris. Now you might say, well, what is it, 45 or 50 stars? Well, people argue about that. It seems like it should be really straightforward, right? Well, the reason it's not straightforward is because lots of stars aren't single stars. Some stars are double stars. You know how the sun has planets going around it. Some stars have another star going around it. So these are called binary stars. So what if there's a binary and that's in the top 40 of bright stars? Is that 1 star or is that 2 stars? It gets a little confusing sometimes. So I usually say somewhere between 45 and 50th brightest star, down the list of ways. It's not famous for being bright. It's famous because it's directly above the Earth's North Pole, as you can see right here. If you draw a line from the North Star to the closest point on the horizon, it'll always point you true north, not magnetic north, but true north, within a half a degree. Its height is always equal to your latitude. So for you up in Rangeley, you're probably around 45 degrees. I'm a little south of that here in Water, at 44 degrees. And if you measure the angle from the horizon up, it'll equal your latitude. Think about if you're at the North Pole, where would you look to see the North Star? If it's directly above the North Pole, that would put it straight over your head, 90 degrees above the horizon. If you're at the equator, your latitude is 0, and the North Star, Polaris, would be right on the horizon, 0 degrees up. Well, for us in Maine, it's 44, 45 degrees, depending where you are in Maine. If you go way up in Aroostook County, it might be 46 degrees up. As you go north, it gets higher in the sky. It also marks the end of the handle of the very faint Little Dipper. These faint stars mark the handle, and this little square marks the pot. I find most people can go out at night and find the Big Dipper just fine, and they're kind of hedgy about the fact that they don't know exactly where the Little Dipper is. They feel like they should know where it is. And most people don't. And it's because those stars are really faint. And remember, if you live in an urban area, the sky is not going to look like this. It's going to look a lot more like this. And then it might be even brighter than this. And these stars will just get washed from your view. You'll find Polaris, the North Star, maybe caught you this bright star, but the rest will just get washed away. So, but in a nice dark spot like Rangeley, these should show up nice and clear. Now, before we leave the dippers, though, I want to show you one more thing. Look at the middle star in the Big Dipper's handle, this one right here. How many stars do you see there? I'll zoom in a little bit like that. You see 1 or 2 or 3? Well, if you have really good eyesight and you're a really clear spot, you should be able to see 2 stars there. Look at it a little closer now, and you can see 1 and 2. Well, that's kind of interesting. It's said that in ancient times, like in Roman times, it was a test of your acuity of your eyesight if you could split that into 2 stars. Well, the interesting thing is if you have a telescope and you zoom in, it's definitely 2 stars. The bright one's name is Mizar, and the fainter one here, his name is Alcor. Now, with binoculars, you can easily see the 2 stars. If you take out a telescope and zoom in further, and this program won't do it, but if you did, this Mizar actually very quickly splits into 2 stars. So there you have Mizar's 2 stars, and Alcor will still look like 1. Scientists with big observatories and using spectrographs to look at the spectra of the star have learned that Mizar A and Mizar B are actually both double stars as well. So this is not 1 star, it's not 2 stars, this is 4 stars. And if they look at Alcor spectroscopically, we find that's a double star as well. We can't split up to see the 2, but we can study the spectrum and realize there are 2 stars there. So that's 2 stars. So this is 4, and this is 2. That makes 6 stars. And the one that I've got my pointer on right there, that one, which is kind of makes a little triangle, is pretty easy to see even with your binoculars. That one is called Ludwig star. I think it was the early 1700s. Someone thought they noticed that it had moved, and they thought it was it's a planet. And he named it Ludwig star for the king of some German kingdom. And but they quickly found it's not a planet, it's a star. But it's kept the name of Ludwig star, and it's believed to be the faintest star with an actual name. All these other faint stars, they don't have names. They have catalog numbers and boring stuff like that. So this may be one of the very faintest stars that actually has a name. So when you look at the Big Dipper and you look at that middle star in the handle right here, this one, realize that when you look at that star, you're not really seeing one star. You might see two stars, but in reality, if you count Ludwig star, then that is 7 stars combined. I think that's kind of cool. So that's right in the Big Dipper. Now go to the back part of the Big Dipper, and right underneath the pot, right at the bottom of the pot, right in here, is something you might see if you have a telescope. You will not see it with binoculars, and you won't see it with your eyes. But you don't need a very big telescope, just a small backyard one. And if you look just in this area right here, you're going to see something. It's actually right down here. Do you see that one that looks a little green? Let's zoom in on it here. Come on. Center. There we go. This one is called a planetary nebula because when they were first found with telescopes about 250 years ago, they thought it might be a planet because it has some size to it, and it's nice and round the way planets look. We now know, these are not planets. They have nothing to do with planets. We still call them that because historically that's what they were named first. They're the remains of stars like our sun that have died. And when stars are the size of our sun die, they don't explode. They have a bunch of processes where the hydrogen is turning into helium, then helium starts turning into carbon. And then before it can go much more, the fusion reactions move out and they push the outer layers away, and they just go drifting away from the center at about 1,000 miles an hour in all directions. Sounds pretty explosive, doesn't it? When stars explode, they explode at a rate of 1,000 miles per second. That's not what's happening here. So planetary nebula are what medium-sized stars like our sun do when they die. This one's called the Owl Nebula. And you can kind of get a sense maybe why it was called that, because these two dark features might resemble the eyes of an owl, perhaps, if you have a good imagination. So you can find that right underneath the pot of the Big Dipper. It's going to be right about there, but you will need a small backyard telescope to find it. All right. So now we're going to go around to the east, and I think we're going to jump a little ahead of time again. You can't do this when you're outdoors, but since we can do it here, let's zoom back just a little bit more. Remember, this is the sky right now around 6:30, which is pretty close to what it is. This is what it'd be right now. What I want to do is I want to jump ahead. Let's give it another hour or so. Let's go to maybe around 8 o'clock. Let's go a little bit further than that. We'll speed it up to right about there. And here we're looking in the southeast, and we have some great wintertime constellations that are visible. And the winter sky is so beautiful in the southern sky this time of year because we have some really bright stars that make some really wonderful constellations. And they all center around a very famous one that maybe some of you know, called Orion the Hunter. It's right here in the dead center. To see Orion, let's zoom in on him now. Look for the 3 stars in a row. It's the only place in the sky you're going to see 3 stars in a nice sharp row like that. And they're all about the same brightness. That's Orion's belt, his very famous belt. But if all you know of Orion is his belt, you should realize there's a whole man standing here. Start with his belt. We have a leg coming down to this star, a star named Rigel. Come back up to the belt. The other leg comes down to this star, a star named Safe. So we got 2 legs, one here and one here. You might notice that the belt looks like it's pulled down a little to one side. That's because of a sword hanging from his belt right there. Above his belt, we have a body with 2 shoulders, a star named Betelgeuse and a star named Bellatrix. And the kids are always getting very excited now because if you're into Harry Potter, you know there's a Bellatrix. And that's named after, that character is named after the star right here. And Betelgeuse gets kids excited anyway. Above Betelgeuse and Bellatrix, above the shoulders, these 3 stars mark the man's head. He's got an arm raised in the air like this, holding a club in his hand. Let's bring it down so you can see the club. The club goes all the way up to this star right here. Actually, those 2. So there's his club. back down to his arm, across his shoulders. His other arm comes down like this. That star marks his elbow, and you've got a curved shield right here. Let's put some lines on him. So there's Orion. He's got his shield out to the end of his arm, his club raised up. I usually draw a line between his shoulders, then a line coming up to his head. As we said before, different programs will draw it differently. I, for example, never put a line between his feet, because if you tie a guy's feet together, he's going to trip and fall, and we don't need him falling down out of the sky. But that's my take on it. Now, this shield is a little problematic. If you look at one program or one book, they'll draw Orion holding a shield. Sometimes they draw him holding a bow and arrow. You can kind of see that. Sometimes he's drawn holding the skin of a lion, because in mythology, there's a story about him slaying a lion. And I think that's how they draw him here. There he is, yeah, with the lion's skin. Sometimes he's drawn kneeling. Lots of times he's just standing there. It's all about how your imagination works. But it makes a pretty good man floating there in the sky. Now, he's got his shield up, his arm out, and a club over his head like he's going to fight with somebody. He's fighting with Taurus the bull. To find the bull, draw a line up through Orion's belt. It's going to point you to this bright V shape in the sky. That's the face of the bull. The red star Aldebaran is the bull's eye, and the rest would be the rest of his face, maybe his mouth, and maybe a second eye here. Maybe he's got one eye a little brighter than the other. Bulls have horns, so start right above Aldebaran. We have one horn up here. The other horn comes up here. His back of his head comes down, and down his back to the Pleiades, this little clump of stars, otherwise known as the Seven Sisters. Now we come back to his face. His body swings down around. So this would be his body right in here. And he's got a front leg there and another front leg coming down like that. Unfortunately, they don't draw him as nicely as I would like. They only give him one leg. But lots of programs will draw in a second leg here, and many of them will actually draw his belly coming up like this as well. He's never drawn with hind legs or a tail. Very often they just do the bust of the animal, and that's what you have here. So we have Orion fighting with Taurus the bull. Now, in mythology, there are lots of stories about the bull supposedly kidnapping the Seven Sisters, and Orion's trying to save them. There's another story where Orion saw these seven young women, decided he wanted to marry not one of them, and not two of them, but all of them, for what that's worth. And Zeus didn't want that to happen, so he put them on the back of the bull so the bull could protect the Seven Sisters from Orion. Needless to say, there's quite a battle going on about it. Orion's not up in the sky fighting the bull all by himself. He's joined by his two hunting dogs, Canis Major and Canis Minor. To find the big dog, Canis Major, draw a line down through Orion's belt, and you'll come to the bright star Sirius. As Sirius marks the nose of the big dog, the way I draw it. So I draw it, this is his nose. He's got an ear there and an ear there, so that triangle would be his head. This program draws, this is a stone on his collar with a neck here, and this triangle is his head with his nose out here. Whichever way you like, you use the same stars. His body comes down like this, right here, kind of an oval shape with a front leg here and a front leg there. Come down his belly, there's a pair of back legs, one there, and a faint tail sticking up. Let's see how they draw him. See, they draw the head a little differently. I like to have him looking at me, I guess. I don't know. And I like the bright star to be his nose versus some stone on his collar. But that's the way I draw it. Either way, it still kind of looks like, I think, a pretty good dot-to-dot dog in the sky. Now, Sirius is the brightest star in the whole night sky. If you go out some night soon, though, you'll notice Jupiter will be brighter, but remember, Jupiter's not a star. Jupiter's a planet. Sirius is the brightest star. The only star that outshines it is the sun, and we don't see the sun at nighttime. Now, just an interesting aside here, if you were a bumblebee, Sirius would not be the brightest star. For a bumblebee, this star right here, named Adhara would outshine Sirius, like twice as bright for a bumblebee. So how is that, you might say? Well, the fact is bumblebees can see ultraviolet light, which we cannot see. We can experience it when you get a sunburn. UV light's what gives you a sunburn. And UV light's more powerful than blue light. As the wavelengths get shorter, they carry more energy. But our eyes can only see from red to violet. This is ultraviolet, which is invisible to our eyes. So it gives off some visible light. That's why we can see the star. but it gives off lots of ultraviolet light. It is a more powerful star than Sirius. And if you could see in UV, this would be the brightest star in the sky by far. So bumblebees see things a little differently than we do. I just think that's interesting. Now, I said Orion had two dogs. This is Canis Major, the big dog. Draw a line from Sirius up past his nose or his ears, depending how you look at it, to the next bright star on the other side of the Milky Way, and you'll see the star Procyon. That's the nose of the little dog. Now, the little dog is a little more difficult to see, so listen carefully. Start with Procyon and then draw a straight line back to Gometia, and Gometia is the little dog's tail. And that's all there is to the little dog, just two stars, one at each end. Doesn't look much like a dog. Kids like to nickname it the hot dog because it looks more like a hot dog than a real dog. But nevertheless, it is supposed to be the dog. I usually draw, this is the eye and this is the tail, but as you can see, they drew it the other way around. It doesn't really matter. Now, so we've got Orion fighting the bull here and the two faithful dogs behind him. I think they're a little frightened of the dog or a little distracted. And what should distract them is right underneath Orion, and that's Lepus the hare. And to see this hare, he's leaping away from the dog, which kind of makes sense. The way I draw the rabbit is this little diamond shape is the rabbit's body. He's got a head here, and you can see his two ears, one there and one there. Come down. This is his hind end with a back leg stretched out here and another back leg here. Come up here. We don't want him to land on his face. We give him a front leg there and a front leg here. They, of course, draw him differently than I do, but at least they give him the same two ears right there. And he is leaping away from those dogs. So we got quite a little scene here. Orion fighting the bull and the dogs kind of supporting him, but getting a little distracted by Lepus the hare. Now, while all this is going on, we have two people standing and watching up here right in front of the little dog, and that's the Gemini twins, Castor and Pollux. This star's name is Pollux, and this one is Castor, and they're two stick people. So let's do Pollux first. Pollux, start with his head. We got a neck here and a body to this star. A leg over here and a leg over here. Come back up his body, and there are two little arms coming out. Nice, simple stick person. His brother, Castor, looks somewhat like him. They're not identical twins. Must be fraternals. This is Castor's head. He's got a longer neck, a shorter body, and a longer body and shorter legs, two legs right there without the knee joints. And they're holding hands here and his other arms coming out like this. So we can draw lines on them too. So there we see quite a winter scene. We've got Orion fighting Taurus, the bull, the two dogs, the rabbit, and then we get the Gemini twins standing on the Milky Way watching this scene going on in front of them. Now, this is part of an asterism known as the winter circle. And the winter circle is just a group of stars that makes a big circle in the southern sky in the winter. And it includes all these constellations and one more. We start with Rigel, the bright star in Orion's foot, and we go down to Sirius, up to Procyon, then up to Pollux and Castor, then way up to Capella, way up here, high in the sky, which is one of the brightest stars in the sky. Not as bright as Sirius, but it's in the top 10. Then down to Aldebaran, the eye of the bull, and then back to Rigel. Nice big circle. Now, all these constellations, except for one, I think are pretty easy to see. The Big Dipper, Orion the hunter, and the dogs. The little dog takes some imagination, but everyone kind of gets a kick out of the hot dog. And Procyon is a really bright star, so it's pretty easy to find. The Gemini twins make pretty good stick people. And so we'll just light them up here so you can see them. And even Taurus the bull, with a little imagination, you can imagine that bull charging at Orion. But Capella is part of the constellation of Auriga. Now, all it really amounts to is this little pentagon, this circle of stars. Now, what do you suppose Auriga could be? Look at it. Well, try to imagine a charioteer, like Ben-Hur driving a chariot, carrying a goat and three kids. Baby goats are called kids. This one takes a little bit of imagination, but that's what it's supposed to be. Capella is known as the she-goat, and these three stars are supposedly her kids. And this is the chariot driver here. And the rest of it, I guess, is his chariot. Some do require a little more imagination than others. But it is part of the winter circle, and Capella is one of the very brightest stars in the sky. So it's pretty hard to miss when you go outside. And that pentagon is pretty easy to see. In Hawaii, it's known as I forget what the Hawaiian name is, like Hutalea or something like that, which means the lei, like a wreath of flowers like you get when you get to Hawaii. And my friend Sean, who lived in Hawaii for a while, always points that out as Hukalea. And I think that's a much better way to look at it, because it does kind of look like one of those leis they give you when you arrive at the airport, right? Or arrive at your hotel and put it around your neck. So you could think of it that way if you like to think about being in Hawaii on a nice cold night like we have tonight. And we see this in the winter time. So might be a good time to go to Hawaii, I suppose. All right. Now, a couple things here to kind of finish up. Then we'll take some questions and see if you have any questions. But there are a couple of things you should look at with your binoculars here. So let's just get rid of all these lines. We'll zoom in on Orion, because that's the best place to start, because it's easy to find. When you look at Orion, what I want you to look at is his sword. So let's just put the lines of just Orion up here, right there. Remember, his sword's hanging down. So look at the tip of his sword right there. And with your eyes alone, you can see there's something kind of fuzzy there. But if you zoom in, right in there, let's get it centered. There we go. With your, like a pair of binoculars, you'll see it looks like there's a cloud there, kind of fuzzy looking cloud, kind of like the Andromeda Galaxy looked like a fuzzy cloud. But remember, Andromeda had a distinctly oval shape to the fuzziness. This is a little bit more blocky, like you expect a cloud to be. Take a picture with a telescope, it'll look like this. This is called the Great Orion Nebula. Now, we saw the Owl Nebula, which was a star that died. This is just the opposite. This is all hydrogen gas, which is what stars are made of. And it is shrinking. Gravity's pulling it together. And where it's really bright here in the center, it's forming into new stars. There's enough hydrogen in this cloud to make 3 or 4, maybe 500 stars like our sun. This thing doesn't look very big, but from one side, like here to here, just the main nebula right in here, that's 20 light years across. Now remember, a light year is not a length of time. It's a distance. Like an inch is a little distance. A mile is a bigger distance. A light year is 1 trillion miles. It's the distance a beam of light will travel in a year's time. And light travels 186,000 miles per second. At that speed, you can go around the Earth 7.5 times in 1 second. So if you go that fast in a straight line for 1 year, that's 1 light year. From here to here is 20 light years, 20 light years across. This thing's huge. But the gravitational attraction between all the molecules of hydrogen are pulling it together. And as it condenses into stars. So if you could be around, let's say in 50 to 100 million years, this cloud wouldn't be here anymore. Instead, there'd be a cluster of very, very young stars. Let me show you where that's already happened. You might say, well, that's a cool idea, but we can't hang out long enough to find it happening because we don't live that long. But if it is what happens, we should find places where it's already happened. Remember the 7 sisters in the back of Taurus the bull that's bull's trying to protect from Orion? So we draw in the lines of Taurus, and there are the 7 sisters, or the Pleiades, as they're called properly. And these are all very, very young stars. There they are right there. There's a photograph of them. These stars are maybe 40 million years old. Now, that sounds pretty old, doesn't it? For a star, that's like being a teenager. These are teenage stars. And, like teenagers like to hang out with their friends, so do stars. They hang out with their friends of groups of maybe 200 or 300. And there's a couple hundred stars in this group. And you see there's quite a bit of nebulosity left around. That's what's left of the cloud they formed from. So if you looked at this spot in the sky 40 or 50 million years ago, none of these stars would have been here. You would have seen a nebula like the Orion Nebula, which we just saw in Orion's belt. So we find stars are born in nebulas, they form into clusters. Then over time, that cluster is going to disperse. There's not enough gravity between the stars to keep them together. They're going to spread apart. Stars don't hang out forever, just like teenagers grow up and some go to college and some just get married and some get jobs and some go in the Army and the Navy and stuff. Stars don't do anything. They don't go to school and they don't get jobs, but they do get married. Because sometimes if 2 stars are too close together, they get gravitationally bound and they orbit each other and they go off as a binary star like we saw in the Big Dipper. So stars do sometimes get married. Now, we saw what happens when stars like our sun die. So there's one more thing here. Go right up the left or the eastern horn of Taurus the Bull, right to the very end. I gotta get it centered here. Let's just center on that star. Now, the Seven Sisters you can see with binoculars, and the cloud in Orion, the Orion Nebula, you can see with binoculars and small telescopes. This object you definitely need a telescope to see, just like we did with the Owl Nebula. This one, though, is going to be right near that star. So you find the tip of the horn, then you see this nice little triangle right here, and then just to the right of the triangle is another star right there. So let's zoom in on that. And to our eyes, it just looks like a star. It will at first, unless you get enough magnification. And then what you'll see is another nebula. This one, though, is called the Crab Nebula. And this is a star that did explode. Only giant stars explode. Before the star exploded, it was at least 10 times more massive than the sun. And those stars go through all kinds of iterations where they end up making iron in their core. And once they start making iron, they can't really fuse anymore. And it collapses on itself. And in a fraction of a second, it blows itself to smithereens. This stuff is expanding outwards at 1,000 miles a second in all directions. And we know exactly when this one exploded because there are records of it. In 1054 AD, the Chinese wrote of a guest star right above the horn of the bull. They said it was so bright you could see it in the daytime. And there are even accounts that you could read by it at night. Imagine a star brighter than the full moon. It lasted for 6 or 8 months, and it faded away. It's a guest. It came for a little while, then it went away. Well, it didn't really go away, just the brightness went away. It's still there, right above the horn of Taurus the bull. So that's where a star has exploded. All right. I think we've covered quite a bit in the sky here tonight. So but let's just review real quick before we go any further. You see Jupiter is set now, it's gone, but we still see the great square of Pegasus over here. Let's just get rid of those for the moment. We'll start with Pegasus. There's Pegasus. His head's now below the horizons because we've moved later into the evening, remember. And right above the top square, we find Andromeda, the princess here. And the Andromeda galaxy is right in there. Go from the Andromeda up above and you'll see the W-shaped Cassiopeia, the queen, the one who bragged so much and get her daughter in all that trouble, right in the middle of the Milky Way. And you see we're at just after 8 o'clock, the Northern Cross or the Cygnus the Swan. While the wings are still above the horizon, the head and stuff is down below the horizon now. So there's the swan right there. Swing all the way over to the north, then we find Ursa Major, the Big Bear, or the Big Dipper. And right above it, Ursa Minor and Polaris, the Little Bear or the Little Dipper. Come underneath them, we come back across the Milky Way into the southwestern sky, and we find our old pal Orion, fighting with Taurus the bull, and backed up by the dubious support of his 2 dogs who were too distracted by Lepus the hare, and being watched over by the careful eye of Pollux and Castor, the Gemini twins. And I'm not sure whether they're watching the fight between Orion and the bull or they're watching this chariot driver with his goat. Hard to say sometimes, isn't it? All right. Are there any questions about anything you've seen here or anything I haven't shown you that you'd like to see? Feel free to speak right up if you have a question. No questions? All right. Well, I will stop sharing.
John, I have a quick question, if I may.
Sure.
I assume the constellations were just a construct by man to try to make sense out of this otherwise just overwhelming visual display.
Exactly.
How long have the constellations that you just described, how long has that construct been around, and how universal is it?
Well, first of all, the ones today, the sky is divided officially worldwide into 88 constellations. If you had been around 100 years ago, you would have found that the French would have their constellations and the British would have their constellations, and the Indians in India would have their own constellations, and the Africans, all over the world, every culture made constellations in the sky. It seems like a natural thing to do. We always look for patterns, the way when you're a kid, you lay on the grass and you look at the clouds and this one looks like a dog and that one looks like Uncle Fred and stuff. We do that with the stars, that was kind of like a man. And because cultures were filled with stories, and it was a way of almost all the constellations in all the cultures have stories that go along with them, because storytelling was such a powerful thing. And so constellations varied from culture to culture, and some made them look this way and that way. Today, of the 88, 48 of those constellations come from Greek mythology. And those have pretty much stayed consistent right from ancient Greece for over 2,000 years. And many of the ones I showed you today are Greek. Orion is Greek, Taurus is Greek, the dogs and such are Greek. But some are, everyone looked at Orion differently. In South America, Orion was part of Cayman. Used the part of the rabbit, Orion, and all the way up to Capella, the she-goat. That was all one constellation, which was supposed to be a caiman, which is like a small alligator type creature. In Africa, Orion was seen as a butterfly. Let's just go back real quick, and a little easier to see here. So, you can look at Orion and imagine this is the body of the butterfly, and you got a wing on this side and a wing on this side, just that little hourglass shape. So different cultures around the world made up their own constellations. And it's only been finalized, I think it was in the 1920s or 30s, that the International Astronomical Union decided to divide the sky up into constellations. And the way they did that was simply by doing this. And they said, everything in this polygon is Orion, everything in this one is Canis Major, this one's Canis Minor. This one here, where there are no bright, that's Monoceros, the unicorn. And I can't even begin to draw a unicorn there. There's no bright stars at all. But that's the region known as Monoceros, the unicorn. So they all have their names. And you can, as far as astronomers are concerned, you can draw the pictures any way you want, which I kind of already discussed a little bit. Did that answer your question at all, David?
It sure does. Very helpful. And this 88, this puzzle, it looks like a 88 part puzzle, makes a lot of sense to me as a way of dividing up the sky.
Yeah, and the asterisms, you may say, I can see the Big Dipper, but I can't make it into a bear. Long as you know that the stars of the Big Dipper are also part of the bear. So let's say you read in the news, or you read online in your news feed that says there's a new comet and it's in Ursa Major, and you go, oh, that's the Great Bear. Oh, that's the Big Dipper. Well, at least now you've ruled out 3/4 of the sky. You know where to start looking with your binoculars if you might want to try to find that comet. So it's a way of mapping the sky, and it's the oldest way. And for most amateurs, it's the easiest way to find your way around the sky. If you want to find the Orion Nebula, we'll find Orion first. It's in his sword. Whereas if you're a research astronomer, you want to look at the Orion Nebula, you type in the coordinates of it. There's just like we have latitude and longitude on the Earth. In space, is called right ascension and declination. And it's just another way of mapping the sky. And it's much more precise, obviously, but, latitude and longitude is pretty precise. But how many people use that to drive your car around the countryside? Because we're all using GPS these days, so we don't even have to think about it. Any other questions before I leave the stars? I'm also, just for a final note here, I am, as David Stein is very aware, I'm vice president of an organization now that's 2 years old called Dark Sky Maine, and we're working to promote Maine's dark sky heritage. And we've been working with Rangeley Lakes Heritage Trust now for a couple of years, and trying to help them do what we can do to help preserve the dark skies in places like Rangeley. The AMC is doing that in the Greenville region. The Katahdin Woods and Waters up around Patton already has a dark sky designation. And we don't give those designations, but we're helping people learn about good lighting, because the difference of a sky like this versus a sky like that is phenomenal. Most people have seen skies like this, or even if you live in Boston, not even this bright. But when you get into a really dark spot, like you might have in the greater Rangeley Lakes area, then you're going to get a sky at night when it's really clear, which it isn't tonight, but when it is, you'll have these incredible skies that even if you can't find the constellations, you can lay there in a lounge chair or on a blanket or in the snow and just marvel at the beauty of it all. And it's really an amazing thing to see. And it's something we're trying to work hard to protect, because all it takes is a lot of lights, even not that many, pointing in the wrong direction, and the sky starts getting fuzzier and brighter, and those dim stars just disappear. So just something to think about. We want lights that don't shine up. Lights shining up into the sky don't do anything for anybody except wash out the sky. I want to thank you all for coming this evening. I hope that in February, I think the date is the 23rd, we're hoping for a clear sky, and I'll be coming to Rangeley, and we'll be looking at the real sky outdoors. We can all dress warm, and I hope you'll join us and take a look at the sky.
John, thanks a million. That was fantastic. Just
well,
great.
You're welcome. It's not the real sky, but it's in some ways it's easier. It's almost easier to teach with the virtual stuff, because you can put the lines up there and help people see it. Ideally, you do this and then you go outdoors and look at the real sky, and then it really starts to sink in, but it's a good start.
Well, it's 68 degrees in my house, and I appreciate that. I appreciate that.
It is cold out there tonight. It's been a long day.
Thank you.
Well, thank you, everybody.
Thank you.
You're welcome.
Bye-bye.
Don't forget to go out and look up.